Okay, so this is 3-7 notes, pages 341 to 345. If you're doing the assignment on the paper, it is pages 347 to 351, numbers 2 through 20. We're going to look at linear inequalities with two variables. So there's a couple of forms that you might see. Ax plus by is less than c, or less than or equal to c, or greater than or equal to c, or greater than c. The solution of the inequality in two variables is one or more ordered pairs. So it's going to be an XY answer. So there's a couple of things that we need to do. We would first want to solve for the inequality for y. So we have 3x plus 5y is greater than or equal to 30. So since this is in the form of ax plus by equals c, same scenario, we would first find our m, which is negative a over b, and we would find our b, which is c over b. And that will give us what our slope is, so we can rewrite in the form of y less than or equals mx plus b. So our first setup is to figure out what is the equation that creates the line itself, which is the border. So negative 3 over 5 and 30 divided by 5, which gives us 6. Now that gives us our m and our b, and that's how they found out the equation negative 3 over 5x plus 6. That's where they got this idea. Now, here's the other thing you need to do. Always look at your y, because the last thing you would do if we were solving by hand for y to get it by itself is divide off that number. So is y positive or negative? If y is positive, then you keep the sign. So you keep the inequality exactly the same. If y is negative, you're going to flip. You're going to flip the inequality. So that is the last step you'll do before drawing your line. So because in this case y was positive, we're going to keep the sign. That's why it became greater than or equal to in our answer up here. So now we draw the line. Because it's greater than or equal to, we know a couple of things. The equal to part of it makes it a solid line. So that line underneath makes it solid. The greater than then tells us that we want to shade above. So the border line is the line itself, and the equal to sign makes a solid line, and the greater than part means shade above. So you really have to think of the equation as being something like this. So what you should think is y is bigger or above this part, which is the line. So when you think it that way, it's easier to do the shading. Okay, then you would test it using a couple of points. So if you pick 0, 0, where is that in relationship to the line? So 0, 0 is right here. That means it's below the line. So what we should expect if we plug in 0, 0 into the equation, that 3 times x plus 5 times y is greater than or equal to 0. If we plug in 0, 0 into the x and y, our result here should be a false statement. Well, 3 times 0 is 0. 5 times 0 is 0. So that's saying 0 is greater than or equal to 30, which is false. So that means that we are shading we shaded correctly. We check out the x. 3 times 8 is 24. 5 times 8 is 40. Well, that is 64. Is 64 greater than or equal to 30? Yes. So we shaded in the right direction. Okay. The next couple of things tells you how to do this in the calculator. Unfortunately, our calculators do not do shading for us, so we're not going to even look at that. The next kind of question shows you have a situation where you have some rearrangement needing to be made. In this case, the easiest rearrangement is simply moving that 14 to the other side and then dividing by 2. Sometimes that just has to happen. You have to do some rearrangement. But remember, when you move across an equal or an inequality sign, change its sign. And then if you're dividing, just divide by the number. So because it's a less than sign, we are dotted, which means that technically none of the points, including the one that I actually drew, are actually part of the solution. And then because it's less than, we're also shading below that line. And again, we test it. So we pick 2 points above and below. Below is 0, 0. That's right here. If we shaded correctly, when we put 0 in here, we should get a true statement. So negative 14 plus 2 times 0 is less than negative 0. Well, negative 0 is still 0. Negative 14 plus 0 is negative 14. So is negative 14 less than 0? Yes, it's true. We're good.